Okay, we are in YouTube. Let's start. Hello, everyone. We are glad to see you. If it is possible, please turn on your camera. We want to see you. Thank you. Hello. Welcome to our introduction webinar. Today, the purpose of this event is get to know each other, our participants, our jury, and our organizers team. And some organization moments. I remind you that main language of CopterHack 2022 is English. And I would like to say a few words in Russian. Дорогие участники, сегодняшний вебинар будет проходить на английском языке. Если у вас возникнут какие-то сложности, то дайте нам знать, мы также проведем и на русском. Thank you. Let's continue. We start with our jury. Let me introduce there are 5 members of jury, and the first member is Oleg Panfilenik. Oleg, please introduce yourself, say a few words.
Yeah, thank you, Elena. Hello, everyone. Again, my name is Oleg Panfilenik, and I'm CEO and founder of Copter Express. And I'm lead jury of this event, of this competition. I'm also I will also provide a money prize for this competition, for funding for this competition. So all prizes that you are going to win, I will transfer you from my bank account. So you will contact me and get the money, no problem. And I also will try to answering all your updates, to get feedback for every updates of every team, and share my experience, my knowledge with you to help you make great projects, and even after to continue work with you together, and maybe continue to do something with your project, maybe together with our company Copter Express, and maybe do something else and so on. So I'm very open to discuss any potential cooperation between you, your team, and Copter Express company. So you're welcome.
Thank you, Oleg. And let's continue. The second member of the jury is Oleg Kalachov. Oleg Kalachov, please introduce yourself.
Yeah, hello everyone. I am the second member of jury. I am the lead developer in Copter Express company, and I also is the lead developer of Clover John Kit that you are going to use. I support this platform. I support the documentation site, and I can answer any your questions regarding the platform and regarding the documentation. Also, I am a reviewer of your pull requests and your articles. I check its format, I check mistakes in your articles, and I will help you to have your article look to get your article into our documentations after you get your projects done. So hello everyone, and that's it about me.
Thank you, Oleg. And the third member of jury is Andrei Korygotsky.
Hello. Yeah, I'm CTO of Copter Express. I'm happy to be in the jury to help you with your projects. The first CopterHack in format like this last year was very great, and I'm looking forward to participate in this one. So good luck with your projects, and I'll be happy to answer any of your technical questions about drones or something.
Thank you, Andrei. And next member of jury is Damian Mooney.
Good afternoon, everyone. I'm Damian Mooney, speaking to you from South Africa at Nelson Mandela University. I'm the fourth member of the jury. Our speciality is on this side of drone construction. We are fairly involved in power units on drones, especially on the larger side. So my speciality to the contest will be the actual construction of the project, if there is such in the invention. And then basically just also commenting on the overall project. Thank you very much.
Thank you, Damian. And the fifth member of jury is Alexander Fomenko.
Hi, everyone. My name is Alexander Fomenko. I'm speaking from Tennessee, United States. I used to work for Copter Express before. Now I serve as a Unmanned Aircraft Systems Lab Coordinator and Professor in Middle Tennessee State University, and I'm so pleased to take part in this competition. And I'm amazed already by some reports in our chat, and whatever you guys are doing, you're all amazing. And I'm here to just support anyone who is as into drones as me. And I've been into drones for 10 years already, and I'm specialized in education and drones right now. And I see you guys already making amazing things, sometimes beyond my own knowledge. So I hope we all learn something here in this amazing competition. So thank you.
Thank you. And this time for introduce our organizers. Svetlana Solomatnikova, are you here? Please introduce yourself.
Oh, hello everyone. I'm sorry I'm without the video, but I'm really glad to see you on the CopterHack event. And also, if you have some organizational questions, I will be glad to help you. Feel free to ask me. Thank you.
Thank you. And Victoria Trubitsina, are you here? Please introduce yourself.
Hi, everyone. My name is Victoria, and I'm the organizer of the aerial robotics competition. It's a CopterHack project competition. I help with organizational moments. And congratulations on the start of the competitions, and good luck.
Thank you. Yeah, I think we have continued with our participants. This is time for your presentation. Please introduce your team, your project, and maybe you will task our jury at the technical moments or organization moments. And let's start with first team is Alata University team. Are you here? Are you ready?
Yeah, I'm here actually. So currently I'm the one here. So I was said that there's no age limit for participants. That's why I decided to participate this year myself. Last year we participated. I participated as a team mentor for 2 teams from Kyrgyzstan, from Alata International University. And this year I would like to do some my own project. And so it was like your company case, I guess, cloud-based simulator like ROS Studio like. And I tried to, so within 2 months, I tried to do just a front-end design of the Clover simulator. So only 3D model and the code. But then I had a small talk with, I guess, so I was had small talk with Oleg Kalachev, I guess, and he said that they actually want the copy of the ROS Studio, and they want like 1 click, and it should be almost be the same as like, so it should have a virtual environment and everything should be like, so it should be similar that you have on your Raspberry Pi, on your Clover 4 platform. And I guess I need a time to reschedule. I need a server. So now I'm working on the server. And so the first advice from Oleg was to deploy your version. So you already had some repository with the Docker container where you have the already, so you have done some work already, and I need to first I need to work on it, and honestly I didn't work. I can show you what I have already done for the front end if I have if I can share my screen, right? So is it possible to show just?
Yes, please go ahead. So Elena, could you
Yes,
please share?
yes.
Yeah, permission for sharing screen.
Yeah, so the thing I have been working on is this thing. So this is like, so this is my original idea, but as I said, I will have to switch to the thing that your lead developer said. You need something like ROS Studio. So this is like the thing I was working on. And also I actually, so this is like code mirror, and you can actually run this one. Currently there's no animation, it will just teleport to the point, I guess, so it will go up for 1 meter and go straight for 1 meter immediately. So if you run this, I guess it should, oh, maybe I haven't deployed, okay, I guess I haven't deployed it to the GitHub yet. Yeah, so it should have, so it says no model called Raspberry on line 3. It means the Python code executed and it didn't find actually its Raspberry model. So I used another library which converts Python code to JavaScript code and can be executed in browser. But as I said, last update. So I will definitely write on November update about all these points. And if there will be enough time, I will also try to deploy your Docker container to run it on my server. Okay, this is all. Thank you.
Yeah, very interesting. So your Python code is executed in browser, yeah?
Yeah, right.
So you're kind of emulating a ROS Pi library in your.
Yeah, I was on the way to emulate it. So yeah, kind of. So I can do a virtual like JavaScript emulation. Yeah, it's possible, but
Okay.
it won't work like operating system. You should understand this. Like it will be
I
like.
think this is a good decision for kind of a lightweight simulation, which doesn't require a server, right?
Right.
I
Yeah.
think if your simulator can do some interesting stuff and you can test some maybe simple programs in it, I think it would be really interesting, and we can actually somewhere make a link to your page so everyone could test basically what Clover is.
Okay.
Yeah, I agree. I think it's a great thing. We also can, if it will work well, add it to Clover image, so you can connect to your drone and open this in your browser and like try the flight, without performing the real flight to check if there are any errors. So I think that's a great project.
Yeah, so thank you for your feedbacks. Yeah, I very appreciate that very much. Yeah, because it took it took almost 2 months to do something simple like this. Yeah, if there is a demand on this product, this project, I can continue this in parallel with the other one. Because I really like this one. I really like simple solutions, and actually it's possible, I guess, even so the main task most of the users try to perform is to like running simple scripts, and the second step is flying with alongside over the QR codes, the Aruka markers, right? So if I'll add Aruka markers, I guess it will be like 90% of most of the demands of Clover users. So maybe they'll.
Yeah, but another interesting feature that Clover users use is possibility to recognize something from the camera. And I think in the browser you can render a camera image, but if users try to use OpenCV, I think it would not be possible to bring OpenCV to the browser.
Actually, there is OpenCV for browser, if I'm not mistaken. It works with JavaScript too. So why not? I can try. I cannot promise you, but yeah, this is the project I'm really interested in. Like it's my passion, visualizing some 3D stuff. And yeah, on the other hand, I will try to do the ROS-like system, but honestly, I did not truly understood how to work with the ROS Studio. Maybe I'll give it a chance, 2 more chances to understand how to work with ROS Studio. For me, it seems to be more like too complicated. I don't know how it can be, how it comes to your Clover Studio users. Maybe it's.
Yeah, advantages of using a server run simulator is that you can use everything that is possible in the Ziba, in OpenCV, in Python, etc. But advantages of your direction is that it doesn't require a server, so it's much easier to deploy your solution.
Yes, right. Thank you. Should I stop? Is that all? No questions.
Yeah.
Thank you.
Yeah, thank you, Rex. So one great project. Elena, I think we're ready for someone else, for the next team.
Yeah, the second team is FTL. Are you here? Okay, they are not here. And second team, EnviroFleet.
If FTL team will join us later, they can tell us about themselves a little later, not in this sequence.
Okay, what about EnviroFleet? Okay, and the second team, Dragon and Tanker. Okay, let's continue. Team Stereo.
Hello, my name is Denis, and currently I am the only member of Team Stereo. As I described in the project description on the issue, my goal is to launch and reproduce the results of authors from Zurich University who made the state-of-the-art obstacle avoidance algorithm. They made it with a collaboration with Intel. Their idea is to use the stereo camera and the neural network, which input is the depth image, and the neural network directly outputs the copter trajectory, which is then fed to their flight controller and executed. As I described in my November update, just simply launching the simulation engine, they use their own simulator called Flightner, proved to be harder than I expected. The instructions are far from comprehensive, so I spent 1 month just to launch this algorithm. However, finally I succeeded, and I wrote my own installation guide. So now you can all launch your algorithm if you have Ubuntu 20.4. In December, I plan to continue experimenting with this simulator. I want to write my Python code and control the copter from my own code. They use ROS for communicating Python and the simulator. So I think this will be quite simple. And then I plan to think how can I integrate their system, their neural network with the real flight controller and try to fly this on my copter. If you have any questions, feel free to ask.
Yeah, Denis, thank you. And what hardware do you use? The same they point in article or something else?
They use their own. They use their own hardware. They have their own copter, their own flight controller. Yes, this was very surprising. When it comes to companion computer, they use Jetson TX2. My copter currently has Raspberry Pi 4, but I think the neural network will still be able to be launched on Raspberry to run at a reasonable frequency and avoid obstacles, at least on the minimal speed of 3 to 4 meters per second. They claim that their algorithm can fly 7 or even 8 meters per second in complex environments such as forest without colliding with obstacles at all. So if they have a powerful computer on board and network can run inference quite frequently, I think that I can drop this frequency a bit, but still fly at 3 or 4 meters per second, which is also quite reasonable performance for obstacle avoidance.
Okay, so you are going to launch it when in December to test on real Copter and Raspberry Pi, or you have done it already?
I didn't do it already. Honestly, I don't think that I will be able to launch this algorithm on my copter in December because there are still lots to figure out about this simulator and about their engine algorithm. So I think I will be able to launch it in January on real copter. For now, I just want to get into their environment and understand their processes.
Okay, please take a record video about testing on Raspberry Pi and how many FPI do you have and so on. We would work on that and share it in your next update.
Yeah, I will share it. I will share the video from the simulation environment very soon. They have quite good simulator. It has a full 3D engine working based on Unity engine. They have various possibilities, various sensor simulations such as stereo camera. So just looking at the simulation is also quite nice because it's quite realistic, both in physics and graphics.
Okay, interesting. Do anyone else have any question?
In my November update, I have put the link to the installation manual. So if anyone else wants to launch it and reproduce the results of authors, feel free to use my instructions. I have the link to GitHub in my November update in our Telegram chat.
If there are no questions, let's continue. Thank you, Denise. Team Space Clown, are you here?
Yes, good evening, everybody. My name is Malishkin Timur, and I am one of the participants of the team Space Clown. And please let me a chance to introduce our project, Copter for Space. We are going to realize the conception of receiving data from satellites of L diapason from meteorological satellites to the Clover, and we are ready for realization, and we got 3 or more experiments, successful experiments, and in November we prepare our article and modify some algorithms. And if you want to know more, you can ask me some questions. Thank you.
Yeah, thank you, Timur. You have a great article already on GitHub. So yeah, it looks very nice. A lot of pictures. So it's interesting to following you with your updates. So waiting your first update.
Okay, thank you very much for your feedback.
Okay, and second team is ROC. Are you here?
Yes. Hi, everyone. Can I share a screen? Yes.
Sure.
A little presentation about my project. The project name is DroneHawk Security. It's a system for monitoring and detecting and catch drone in the air. Airspace is a problem. Airspace safety system, safety in quadricopters is an important problem, as I think. The project, our project is aimed to research a solution problem to protect a private territory. Drones continues to grow in popularity, and it's maybe security problems. Our system offer one of options for solving security problem: monitoring, detecting, and capture drone to prevent incidents. So how it works? Our project in first stage, it's research stage. The drone rise into air, receive approximate coordinates and of another drone, search another drone, and follow and report coordinates of the found drones and catch it. Development plan, how we should solve this problem. First model, it's monitoring, then detection module. We think that manual aiming at the target and following, it would be a prototype stage. Then we try to automate drone detection by camera, training and neural network to detect different types of drones. Then next model, it's following, getting the coordinates of location, follow the drone, calculate the direction to drone. And next, it's catch model, catch the drone, and inform owner about detection and warning. It's a drone communication. Main challenges, it's a problem of detecting drone in 360 degrees. And second, that how to intercept, catch a drone. That's all. Very glad to receive feedback.
So how you are going to solve these two challenges?
I think that in CopterHack, I can solve only prototype and detect only drone in line, in not 360, only in how camera can catch degrees. And second, I don't know, it's maybe you can help with idea.
And what about to intercept the drone? How you are going to intercept it? What was the solution for interception?
So maybe it's mechanical catching hand. Maybe it's other software solution. It's in research stage now.
Okay, and why you choose this topic? Why you want to make this particular project?
So I think the security, it's very important for people and for drone owner, and it's very interesting to try solve this problem. That's why I choose it.
I would be curious to get to know what problem are you trying to solve with this project. Like, you don't have to answer right now, but maybe next time we can talk about it. You can deliver some examples of real world situations where the system would be applicable, and also in which jurisdiction it will work. Because like in, let's say in United States, there's a lot of rules and regulations about where drones can and cannot fly, and maybe this system could be useful sometimes, but at the same time, you cannot harm other people's drones by law, because it's like this is a federal crime to attack other drones, and like if they're flying in FAA, your jurisdiction, which is all the airspace is federal, like okay, and in different countries, of course, there's less laws and regulations about that. But the main thing is like, what kind of problem are you solving? Is that what hazards are you mitigating by the system? Is it drones by the airports or drones over prohibited areas or anything else? Thank you.
Thank you for questions. I agree that there are many solutions of this private airspace, private territory, and it's legal. Yes, I agree. I think maybe first for me it's detect drone and follow it. That's my challenges first, I think.
Another question. So you're thinking or working on what method of detection? Is it optical, or is it kind of radio location, or using drones, like intercepting drone signal or something?
Optical, yes. Camera, optical camera.
Just from
sorry. Actually, there is a bunch of different anti-drone solutions from different vendors around the world. So do I understand correctly that you are going to create something very cheap, the most simple, affordable for everyone, right? Like a DIY project? Or are you going to make some industrial solution?
Sorry, Oleg, don't understand question.
Yeah, I mean, there are a lot of different solutions for interception drones and anti-drone solutions around the world, and for different prices and so on. For military purposes, for industrial purposes, so on. So are you focusing on create something as cheap as possible, something very simple, or are you going to do something industrial grade?
I think it's would be cheapest than other methods, other options.
Okay. Damien, do you have a question?
Yeah, it was just on the same idea as Alexander there. Visually, I can't imagine being able to detect a drone at any sort of distance. If you imagine one drone looking for another one at a distance of more than 10 meters, there's just too much visual noise in the background for you to sort of be doing a 360-degree scan and then try to find that drone with other objects in the background. So like Alexander was saying, you normally want to start with some sort of an RF detection, in other words, just signal strength, because that way you cover 360 degrees very, very quickly. You can already get to a stage where you're saying that drone is transmitting, there's a signal coming from my 12 o'clock position, face the drone that way, move forwards, and then by all means visually you can start to look for it. But I think anything more than about 10 meters with background, with items behind the drone, I can't imagine you picking it up. My 10 cents worth, I've never tried it, but I would think RF is the way to go initially, and then maybe over to a visual system.
Yeah, I agree. Thank you for feedback. It's very good. And I think about it that distance is too short, and many problems, and to detect in sky other drones. Yes, I think it's maybe hard. Would be hard. Thank you. Any questions?
Okay, thank you, Vyacheslav.
Thanks a lot for feedback.
Thank you. And the next team is Mukt. Are you here? Okay, they are not here. And second team, Athena. This project.
Hello,
Okay.
Hello, everyone. Are you listening to me?
Great.
Yeah, I think yeah.
Yeah.
Oh, thank you. So we are a Athena team. We are core of part of seminar group that we have a core named Aero Robotics Core. Seminar group is solution for engineering, mechatronics engineering, and we are an extracurricular group at University of São Paulo. So we are the Brazilian team, and we are very excited about this competition. Our project is based on swarm manipulation, and the name of the project is Swarming Blocks. So we intend to develop tools that make easy and effective to apply a clover swarm on a railroad problem. Our group has 6 members, and we divided the project based on what tools we want to develop. And we started our project in October, working on the application article. So we are our main challenges on the project is to choose which tools that we can have to manipulate a swarm and to apply to a real world problem. And the question is how we can manipulate a swarm, and which functionalities would be useful on a mission that we apply it. And we are working now to solve this question. We just do some ideas and organize it to work it on the project. And the idea is to bring the application of a clover swarm easy and effective for not a single case problem, but for many as possible. And that's our idea. It will not for every problem that we can take, but for most of them, for problem that can be solved more effectively with swarms, and that's the idea. And we work on it, and we'll try to show the results to reach our objectives until the end of the competition. That's it.
Yeah, thank you. It sounds interesting. Yeah, interesting projects for some maybe very simple implementations of drone shows. If you're talking about a regular practice for coding drone shows, as I know, people use Blender and create animation in Blender, and after that uploading it to every drone, the different flight missions regarding to the Blender animation. But for some simple animation, maybe they can use Blockly in Clover, and it sounds very interesting, and I personally want to see how it will be, and looking forward for your demonstration.
Yeah, the idea of Blockly not to be a thing that only who know advanced things about Clover can develop. It's the educational topic involved too, and the application that you said for swarms that the people take an animation and go to a show. It's one of our ideas of application, but not only one. We want to apply vision techniques to do real not so real problems too, like mapping with much drones, or doing a search on an area with more than one drones, or to optimize the processing with two drones. One drone, it's one of our idea. One drone makes one thing in one function, and other function that both working together can apply a really complex function that on a Raspberry it is needed. So our idea is to advance on other problems. And that's it.
Yeah, good, great.
Thank you.
Thank you.
And let's continue. Second team is Edjanun. Are you here?
Hi. Hello. Yes, we are. Hi, we are a doctorand student from Poznań University of Technology from Poland, and we prepared a short animation that say how all concept of our project. Maybe I share our screen. It will be also in the chat link. Can you see the video?
Yes, we do.
Yes.
Okay.
Go ahead.
We have a mobile platform with the drone on the back, and our mission is to send a new home position of the drone, and the drone can't know new perfect location. So okay,
Sorry, it wasn't clear. So what do you transmit to drone?
Okay, we have a mobile platform. We start in one place, and we move this landing platform to the another place. And we at the beginning, when we start, we don't know what the GPS position of the landing platform is at the end. So when we move the landing platform, we send the GPS location of the endpoint, but of course it isn't as accurate as we want. So we need a vision-based landing, which allow to land in the correct with the correct rotation at the same place on the landing. So it's a vision-based landing, and we want to use machine learning, and we want to enable it by using Intel neural computer stick connected with Raspberry, and it's all.
And for detection, this landing spot, it's you don't use any fiducial markers like Aruka markers and so on. So the drone detects on landing spot without helping of any markers, right?
Yes, we want to prepare the landing mark, not the April or Aruko tag. It's kind of no H or T sign to allow the correct rotation of the drone and so on. Yes.
Yeah, and what's the reason for using neural networks?
We also want to detect the person, people's nearly in the landing place, and avoid to make the landing more safety by stop the action if the person in the area of landing. So to ensure the safety in the landing area.
Okay, now it's clear.
So you detect motion or you detect persons or faces?
We want to detect only object thing. We plan to make the box area in the behind of landing platform, and when someone is in the area, we want to stop our landing. So we need to make more than the small landing, the area of safety, and if somebody is in this area next to the landing place, we want to stop landings and send a warning message that that somebody is in the landing place and the process is.
So will this work if the person is standing, not moving?
It's also with object detection. It's also possible to detect this person in the area. So we want to use an object detection as a main algorithm. We have two labels to detect. One will be the landing place, another the person or the object which can stop the landing process.
All right. One more question. Is this part of your doctorate research?
No. No, but it's connected. The research area is connected to vision algorithms and edge devices, but this is not our thesis.
Okay.
Some question? Or? Is there maybe another question?
How do you communicate with a drone?
Now we use the ground control. We are still waiting for the platform, but we use another one in in different competitions. So we communicate with the ground control and ROS-based algorithm like a ROS param server and something like that.
Thank you.
Thank you.
So I'm going to use a simulator for testing, or only real testing with real flights?
We prepare a Docker image of a simulator. It's available in our GitHub repository, linked to the pull request. If someone want to try, it's also available. So we now prepare the Docker, and we run the simulation. We want to prepare the environment of the simulated situation, but it's a plan for the December.
So you're going to use a for neural network, you're going to use a simulated data set in Gazebo or using something else?
Yes, also we plan to prepare data, of course, in the different environment, but we want to connect it to, we want to add it to the simulator in Gazebo. Yes.
Okay. Okay. Looking forward for first results and some video demonstration.
Yeah. Of course. Thank you.
Thank you. And second team is Clover Rescue Team.
Hello, my name is Kirill. I'm the part of the Clover Rescue Team, and the main idea of our project is to rescue some lost drones. The main idea to install on the Clover or on another drone, but yeah, well, based on Clover drone, the GSM module, which will send some coordinates and telemetry information in the case of some crashes or loss of signals. If the main task or case or scenario of uses this project is when the drone lost connection with the pilot, yeah, and the pilot can send some short messages through the GSM wire, and the drone will send some telemetry and information about position, and can get some information for the battery and etc. So if the drone is okay and it can fly, but there is no connection between the drone and pilot, we also can send the signal to fly it over the pilot if it's possible. So now we have some problems with interpretation of data of telemetry, but we do some steps for solve this problem, and we hope in for 2 or 3 weeks we can make some prototype to test it. Be glad for your questions.
I'm sorry, what is the name of team?
Clover Rescue Team.
So you are going to create your own hardware, right? or use some?
We will, based on the already exists GSM models, but we want to to connect some Arduino and GSM models and Arduino with the Clover. It's the first solution we want to test. And the second, we want to connect some models directly or to Raspberry Pi. We want to.
And why are you going to use Arduino first? Why not using Raspberry Pi?
Just because there is not a lot of experienced work with Raspberry and a lot of experience with Arduino, but we think that it's with the Raspberry will be easier, and we are going to modify our project for Raspberry.
So what will happen if the drone is turned off? Can I find its location in such case?
Yes, because we want to add some a little emergency battery only for Raspberry or Arduino for Raspberry for now.
Okay, so it will be something like a black box, right?
Yes, the black box and maybe the part to the rescue button for save the drone, because it can fly to the start position. If we will send the location of the pilot, drone will can make a trip for a pilot.
Okay,
maybe someone.
Updates.
Thank you.
So the drone cannot be rescued if there is no GSM coverage, right?
Yes.
Oh, okay.
Thank you, Kirill.
Thank you.
Next team is CopterHack. Are you here?
Yes, we're here. Hello all. 1 second, I will demonstrate the desktop. Oh, I can demonstrate desktop. Okay, without. We are a team of students from BMSTU named Bauman, and with the project CopterHack. And we are deploying a flying controller board for PX4 firmware. And the main feature is the installation of Raspberry Pi Compute Model 4 directly on the board with flying controller. The FMU will base it on STM32F4 as in FMU V4 right now, but the set of sensor is updated. Components are selected based on availability, and you also can see all updates for now in the pull request on GitHub. And second feature of our flying controller is availability of mesh network, and it will be introduced by my teammate.
Oh yeah, right now we are working on a decentralized mesh network based on our flight controller. This mesh can be used to control several drones while being connected to only one of them. This also gives drones a new way to communicate with each other, regardless of Wi-Fi network. Mesh will probably be built on ESP mesh or a Bluetooth mesh. This is the thing that we are testing right now, so we can choose which mesh we will use in our project. I guess that's all for now. Feel free to ask questions.
I have a question. So, as I understand, you're making a flight controller that that will have a place for RPI CM4, right?
Yes.
And I think what is possible to do on ESP32, isn't it possible to do on an RPI? And if you get rid of ESP32, your board would be easier.
Yes, that is the thing that we're testing right now. We're thinking of making our mesh based on Raspberry Pi compute model for Bluetooth that is integrated. So we'll just test it out and make a decision.
And you said that you are going to use FMU V4, right?
We use the microcontroller from FMU V4, but sensors and config will be an hour.
I mean, the standard firmware will work on your controller, or you're planning to do a custom firmware with updated sensors and so on?
Yes, we doing now custom config for FMU for PX4 firmware. You can see it on my GitHub.
Yeah, this would be more difficult to do if you are will be required to support your own custom version. It's not so easy, and maybe to make a board which is compatible with some existing board would be better, but if you want to make a custom board, it's okay as well, I think. But
yes, true.
You're going to need to support your own fork, or you're going to need to send your custom board to PX4 upstream, so they would merge it. And I don't know if they would merge it, but
yes, we think about it, and if our flying controller will be really nice, we will trying to make a pull request for PX4.
On this board, what ports are you going to place? What maybe some additional sensors or
yes,
what do you find on this board? So, or just a simple carrier board for Raspberry compute model with PX4 or something else?
Yes, we have a picture of our PCB logic schematic, but I can't turn on demonstration of display. I can send it in CopterHack беседу. in
Yeah,
Telegram.
you can send on CopterHack group. Oh, yeah, Yelena, could you please share permission for screen sharing?
Yes.
No, it's my problem on computer.
Okay, okay. Please write your first update and send or you have all pictures of design. Do you have already the design board?
No, right now we working on schematic, and after it will done, we starting developing the board, because schematic is the difficult too, because we need to create power logistic and over features.
Yeah, but also think about connectivity. What connectors will be present on this board? And
Yes,
so
yes, we have this all, and I send a picture in a group with all connectors and.
Yeah, and what software you are going to use for PCB design?
I was trying to use Altium KiCad, but stand on EasyIdea.
Yeah, I think EasyIdea is a great choice, and you can share your project on EasyIdea with everyone, and
yes,
go and
it is.
see your project online.
It's very simple, and all features what I need is here, like different spare and over.
Okay. Okay, thank you.
Thank you. And next team is Cleartron.
Hello. I'm a student of Moscow Aviation Institute. I am Rufin Daniil. I am doing a Cloudtron project. I also have Evgeny Radika on my team. The main idea of the project is to create an addition model for quadrocopter that will allow connecting several clovers into a rigging assembly of drones. A program will also be developed that will allow calculation the trajectory for connection drones. That's all. Question?
Thank you, Daniil. Any question?
I'm sorry, I misunderstand. What are you going to make first? What are you going to show us as the first?
I don't understand.
Yeah, I mean, what are you going for beginning to make it as a first step and to show us some first
we create the model prototype and create 3D model and build this model on the real.
I'm sorry, what's the name of project again?
Cleartron.
Sorry, Oleg, from my side, I didn't quite get the project there. Could you give me a quick overview, if you don't mind? Might have been lost in translation. Sorry, Rufin, would you mind just giving me a quick description of the project again? Just the first part of the description. I don't think I understood correctly.
By the way, you can read in the article.
Yeah, I'll do that then, not a problem.
And if it's in Russian, you can use Google Translate.
Yeah, I'm sorry. Yeah, I have read the description of project. So you're going to make some a firm connection of two Clover drones, right?
Yes. Now too, as you can use this model for connection 3, 4, 5 Clever.
Okay, and well, what is the stage of your project? What have you done already, or nothing yet?
Model connection, clever model connection, and program управление коптером. Можно на русском? Прям плохо.
Yeah, you mean control model for drone.
No.
Yeah.
Yes. Program drone.
Okay. Just share with us on the first update, and also send a picture of this 3D model of connections, and some video demonstration of how you're testing a software if you did it already. Yeah, because it's an interesting topic. I remember on previous CopterHack 2021, there was a team that who tried to do the same thing, but they don't, or they didn't.
Thank you, Daniel. We are waiting for your update. And next team is Troy Ronov. Are you ready? Okay, the team not here. And next team Inondro.
Hi. Yes. So we are a team in Inondro. We are a startup in Aachen.
Connection is lost, I think.
Yeah, we don't see you, don't hear you.
I think
hi.
Oh, hello. Yeah.
Yeah, I think my internet was disconnected.
Yeah.
Yes, I will do it without the video because it's a bit bad. Yes, so we are a startup in Aachen, and last year we did the generative design frame with the Aachen Drone Development Initiative. This year, I don't have a presentation yet, but we want to do the company case, designing the FMU V6U with the Raspberry Pi compute module. The stage right now is that we are thinking on what components to place on the carrier board of the compute module, because it's supposed to be very small at 55 by 40 millimeters, I think. So we are thinking of doing like two circuit boards, one with the most basic functions like the RC input, one camera input, and CAN bus and power and stuff like this, and then to do another one with more external functions like another camera port and yeah, more USB ports and stuff like this. So you would be able to do one circuit port and have the drone flying, and then you can connect another one on top or bottom of it to connect more external devices. Yes. Any questions?
Yeah, can you share with us some design already of connectors?
We don't have one yet, but I will write the update tomorrow and then put it on the GitHub. But yeah, so I have a list of connectors that we want to have on the basic version. It's S-Bus, CAN, PWM, like for the motors, power, USB-C for the PIXHawk, one Talon port, one I2C port, and one camera port. I think this is the most basic version of what you need to be able to use it with the Clover platform. So you want to connect the camera, obviously, and you want to connect the basic functions of the drone.
Yeah, I think it's also GPS is needed.
Ah, yes. Yes.
Yeah, maybe CAN bus is not needed, but
yes. But I think we want to include CAN bus. I think not yet, but I think the whole PX4 direction is going into more CAN bus accessories. And we have already done for another project, we have done some CAN bus sensors ourselves. So we would want it on there. There's also, I think there is some GPS already available that go over CAN bus.
And for PCB design, you're going to use also EDA or something else?
We probably will be using KiCad.
Okay.
Yeah. Yes. And we are thinking, we want to use the whole standard components, like the STM32 H7, I think it is. But we will have to see if all of those are available, because the whole microcontroller market is really unstable at the moment. Yeah, I think that's it from our side.
Yeah, okay, thank you. Waiting for first update.
Yeah.
Thank you. And next team is Vina. With project visual navigation. Guys, are you here? Okay, and next team is Business Gusi. Are you here?
Hello, everyone. Do you hear me?
Yeah.
Do I have any echo, or you can hear me clearly?
That's great.
Yeah, I hear you clear.
Okay. Can I share a screen, please?
Yes, you can.
Okay, 1 second. We have a pretty small presentation today. Our project is called a drone rover climbing system. We participated, we tried to participate last year with different members of the team, but we haven't finished the project because of different reasons. And this year we wanted to do it again, basically because we haven't developed it last year. The whole idea behind the project is to use 2 different systems of a drone and a rover, and to minimize its disadvantages and improve its performance. With the drone, you have limited flight time and you can get heavy payload, but you are free to move around. And with the rover, you can't see above your sensors, and but you can carry heavy payload. Example, I would tell about our testing stand. We plan to do a vertical climbing test where the rover has a hook deployment system and several cameras, one for SLAM navigation and another for Aruka navigation as a safety anchor. Drone flies around the area and creates a map of the location. Then, for example, select some obstacle which rover cannot pass on itself. For example, a pillar or a slope. Deploy the hook around it and then lands on the rover. For charge, for example, then the rover can get around the obstacle with its cable winch, for example, and later move with the great map. The system can be used for some delivery equipment, for example, to hard-to-reach places where it's pretty expensive or not possible to send, for example, helicopter to set some precise sensors or polluted regions and dangerous for humans, or some kind of delivery in such regions. I haven't presented my team. We consist of 3 MIPT students. One of the member of my team is Simon Albert. He's here too. Right. So right now we don't have much progress, material progress. We are testing SLAM. We're calculated and designed hook and winch systems, for example. Right now, set up communications between rover, computer, for SLAM and a drone. And we're planning to finish some SLAM testings in December. Several of planned features are listed here. It's like drone hook deployment system, navigation with SLAM in our test area, because the task of overcoming different obstacles is pretty hard for rover and drone. And right now we have 2 plans where calculations would be held on a drone or in a rover. Depends on will be able to get some hardware like Jetson. That's all.
Yeah, I just want to add some words to Igor. I want to say that today we try to deep into the SLAM and point cloud to understand how we will organize our connection between the rover and drone, and we have a bit progress with that. And also I want to add that it's important for them to complement each other, because drone has their problem and the rover has their problem, but together they can solve the very hard tasks. And the main tasks, of course, it's delivery tasks. For example, you can deliver the medicines to hard-to-reach places, as like such as mountains or snowy city, and it's easy to reach them when your drone and rover together. But it's extremely hard to do that if you have only drone or only rover. Thank you.
Yeah, okay, thank you. So waiting for your updates and looking forward how your rover and drone will cooperate together.
Okay.
To solve SLAM task.
Thank you.
Mm-hmm.
Thank you, guys. And next team is Fiel with Project Drone Delivery. Are you here?
Fuel.
Fiel. Yeah, sorry. Okay, and next team, DJS Phoenix.
Yeah, can we just share my screen? I guess it's busy. Aman?
Hello, good evening, one and all present here. My name is Aman Bhatt from DJS Phoenix. So we are the official drone team of DJ Sangvi College of Engineering in India. Next slide, please. So we are a community of drone enthusiasts who design, analyze, and manufacture pilot drones. So let's talk about the journey of our team. So next slide. Okay. So I would like to brief you about a short journey of our team. So we started in the year 2017, where we first participated in the Technician Delhi, which is an international level competition about drone racing, and we managed to pull off the 5th position. We also participated in Innovation Pavilion, where we managed to pull off 3rd rank. That's right. We also participated in IMF 2019, and we were nominated among the top 25 teams in the world. And we were also nominated for Indian STEM Awards in 2020. And our recent achievements include we managed to pull out 4th position in Indian Drone Racing League, which was held on the virtual platform. And further, the challenges and some points of a project will be explained by my colleague, Mr. Shubham Mehta.
So thank you for the warm welcome. So let's begin with the challenges. After participating CopterHack, there are 3 major challenges that we are actually facing. First one is how to integrate the Raspberry Pi and with our FC and learn the basics, since we have the major experience, I guess of 3 years in building only FPV drones. So it's first time that we are trying something new. We are going to build a completely autonomous drone, which will be capable of scanning the AR codes and going to the and directing the dedicated cars. The second major challenge would be, I don't think it's a challenge for us, but it's the language bridge. So most of the things that comes on the platform of CopterHack are in Russian language. Many of the participants send the text in Russian language. So to translate that thing for us, it's a bit difficult. So usually we use different type of translators that are online available. And what we think is by the end of CopterHack, we will surely learn this Russian language. Finally, it's also the team. Our team consists of 4 seniors and of undergraduate students, from which major students are from second and first year engineering, where there's only 4 seniors which are from the final and 3rd year background, computing background. So even that's a challenge for us. So let's begin with why coeds. What made us to participate in coeds? So the thing that attracted me towards coeds was its platform, a completely open source platform where you can learn a lot. And the main thing that attracted me was the experience and the information that I'm getting from coeds. The I can say education, in terms of education and in terms of experience, it's completely new for us. So we want to give a shot for coeds. So let us begin. Let me introduce to my project what exactly we are trying to build. So let's take a scenario where a person is trying to park a car. Okay, so he has traveled to some mall or some superstore, and now he's finding his place to park a car. So he finds a place, and this will be his reaction. Yeah, you find out the place, but sooner or later, some other guy comes in between and he parks his car. So what will the reaction of the user is? That look. So to avoid this thing, we thought that let's make a drone. Let's make the perfect use of drone. Who will direct us to a destination. Who will direct us to the parking place which is available for us. And after that thing, we are right now just learning those algorithms, those programs. So we can finally build that drone, which will be used in many super malls or markets which will direct the user cars to their destined parking lot. So these will be the features for our drone, which will help the user to get to the perfect parking lot without any getting problems for finding empty space. So once the user gets the parking space, yeah, his or her time is safe. Apart from time, you are actually get the space for that, and this will be the final reaction of the user. Yes, we finally parked the car to step this. So that's from our side. Thank you for presentation, and any questions? We are open for.
Yeah, hello. Yeah, thank you. In your article, you talk that you're going to use a drone that calls Ikshana, right?
Yeah. The reason behind Ikshana.
Tell more about it.
Yeah, sure. Actually, Ikshana is an Indian origin name, which means a drone having 3 eyes, or you can say a drone. It's an ancient, or you can say animal, sort of mythological animal. So we gave our drone that name. Since our drone will be having 3 cameras, one will be scanning the AR text, which will be there on the parking lot spaces. One camera will be what kind of scanning all the directions, and the final camera that will be on the back side of the door. It will keep a watch on the car or a vehicle that's following. So every time a car gets stopped, or if a specific distance gets increased between the drone and the car, so drone will stop moving ahead and wait for the vehicle to get into that specific distance, so that the driver can easily track that drone to the parking space. It should be not like that the driver is stayed behind and the drone has already reached the parking space. So to avoid that, we added all the 3 cameras, and we named our drone as Ikshana.
Do you have any images of this drone and hardware you're going to use?
Yeah, actually, we are working on that same thing. What we believe is to first learn from the basics. If our basics are strong, we will be able to capture higher edge. So as of now, we have only FPV frame, and we are building on that frame. Our major concern is how should we connect the Raspberry Pi to our FC. That's a Pixie Hub. So for that, we are working. So from this month, from December, we will start working on that same. We have just completed our course on how to connect Raspberry Pi to Pixie Hawk, and how we can integrate both the models, how we can run ROS and Gazebo, so to make it completely autonomous too. So our building phase will be starting from the next month, it's December.
Okay, we're looking forward for your updates and images, maybe some video demonstration in December.
Okay, yeah, sure. We will try to send you all the images and the video materials that we will be having for the month of December.
Okay, thank you. And next team, Jedi 5081. Okay, they are not here. And next team, Lucky Flight. Okay, and next team, Solid Eye.
So I'm here. Good evening, everyone.
Hello.
As you may know, there are already drones with lidars on board, but my project is about lidar, but I'm not going to scan surface. This is like RP lidar, which is used on some ROS learning robots, but it can be installed on drones. It's light. It weighs about 40 grams for prototype, and its energy efficiency is much higher. Its consumption current is about 200 milliamperes, which is much better than RP LiDAR, which contains some motors. So we're going to make it affordable for almost everyone. This price could be about $100. So what is it actually? It can be used for autonomous flights indoor without ARUC marks on or something else, because it can build flat maps of the indoor space. It also can be, we guess that it can be used for 3D map building, because it can scan layers of space and connect it with each other. And also it can be used for autonomous flights with known map of indoor space. This device, because of its lightweight, its low energy consumption, can be used with small drones for maybe designers, builders, or even for rescuers to maybe research areas of technical disasters. So right now we have a prototype with sensors installed on it. We use VL53L1CB from ST Microelectronics. These are laser sensors, which can get a cloud of points, or about 4. It has a matrix with 16 per 16 pixels, but the areas are divided by 4 by 4, so we can get 4 pixels per each sensor. We are installing them round. I can share the screen and show the look of the prototype and the concept which we want to develop. Okay. That is it. This is a prototype. This is a concept, and the prototype looks like this. There are 14 sensors, VL53L1CB. There's STM32 board and Raspberry. Here is a prototype which we use for testing with ROS. So this device can be used with SLAM and Gmapping for navigating with drone, building maps, and moving by the map. Thank you.
So all of your lasers are connected to an STM board?
Yes.
And you pass the information through UART or something else?
Yes, we use UART to connect.
And I was going to suggest, but I think you're already done that, you should make a ROS point cloud, and you already made it.
Yes, we have a ROS point cloud. I have a video where we can see ROS visualizing data from the device. So now the main problem is to actually install it and connect with Clover, which I hope will soon be with us.
So you should run some localization node that would take point cloud as an input and give a position in the map as output. And this position you should put to vision position estimate topic of Clover. of Mavros?
Actually, yes, this is the plan.
And this is your plan, but you have not already done it?
Yes, that's a future.
Well, I think this is a very interesting project, and I'm interested in how it would work in Clover and in a real flight.
Can I ask a question?
Yes, of course.
The question is, can I use LiDAR from some other Gazebo models as a Turtlebot and connect it with Clover actually in simulator and try how the program will work?
Yeah, I believe that there is a generic rangefinder sensor in Gazebo. So you take the model of the drone, and then it's an XML file, and then you add to this XML file or all your rangefinder sensors. You set their parameters, which is max distance and noise, to the parameters of your rangefinder. And then you get all the data from this simulated rangefinders to ROS topics of type range. And then some program, and actually there is a program, there is a RAID node that can convert multiple range topics into point cloud topics, and that would be the simulation of your point cloud output. Or maybe I believe that there is such a node, but if there is no such node that you that you can write it yourself, it's not so difficult, I think.
We've tried to do this with Turtlebot from the WorldPro, and there it's made just with SLAM and gmapping. So these algorithms can get just a raw array of ranges. And transfer it, build a map with it, and also navigate on this map if there is a file.
So your actual sensor would give an multiple range topics or one point cloud topic?
I guess we haven't decided about it right now. But I guess this isn't much difficult to change the format of data if we want.
Okay, I think you may support both output formats.
Okay, thank you very much.
Very interesting question, very interesting project. And I have a question about hardware. What is the stage now? I mean, your PCB integrated circuit board that you have shown us as design. Do you have already some prototype, or are you going to manufacture it in the near future?
We're going to order actually the board on which we want to put the sensors, because right now it is just hell with a lot of connectors, circuits.
So when do you expect to get the first board?
I guess we expect to get the first board when we will actually get the result that we want for, because now the device can give frequency of about 10 FPS, which is we think is about less than we want. So as we will be ready to make frequency higher, we will order the first board and try to make the device.
Okay. So it's not soon. So in the near future you will continue to work with prototype. Okay, I see. Okay, thank you.
Thank you. And the second team is AIU Clover.
Yes, I'm here. Good evening, everyone. So I would like to represent my team. I'm the only member of team right now. And main idea of our project is creating an artificial intelligence based flight log analyzer, which means drone will face some kind of problems. It could be like interference or collisions. And instead of waiting for end of flight and then reading and analyzing what went wrong, our analyzer will try to read it by himself. Which I mean, drone owners usually review like flight logs after when something went wrong. Our analyzer will be figuring out and exactly the time when a drone will be flying. So we will be using collected data from Clover flights and a Clover platform. That's it. That's the main idea of our project.
So what would be the output of your artificial intelligence? Which information?
Output will be a showing of what exactly went wrong. Like yeah, I meant by that we're using the special website to see like the destination of our drones, see the way when it went wrong, like which problem it faced. But with our analyzer, it will read it by himself. Like a person doesn't need to go through all the data trying to see what went wrong.
So basically that would be kind of a list of possible problems, for example, 100 problems. And,
yes.
And your algorithm would pick the most like one.
Yes, exactly.
And you're going to make this list manually.
Yeah, we are still working on it, but for now, yes, we're planning like that.
Okay, this is interesting idea.
Thank you.
Yeah, this idea is interesting, but it's interesting to test it, to have something for test. So what could be the minimum valuable product of this, and how soon could you launch the beta testing for, I mean, not beta testing, just some demo example to uploading my log file and get some output. So when you can present us something, show something for try.
Yeah, I understand your question. I was hoping to actually get some more new members in my team and try to realize until the end of December. So in the next update on next month to show you some examples of our beta test.
Yeah, sounds great. Okay, we're looking forward for the next update with the link for testing.
Okay, yes.
Thank you.
Thank you.
And next team is Scout Drone. Final team C300-05 right here. Okay, guys, are there any other teams who want to say about their team or project? Maybe we missed you. Okay, I think that's all of you. And thank you very much. There were 15 teams with us. That's so cool. And I would like to say you one organizing time for organizing moments. It's important to send updates every month, or you not be able to continue participating in the competition. And I would like to remind you about our face. This can I share my screen? Yes. Here you can see all of teams, all of you article. And their stage of CopterHack 2022 now is left qualifying stage. We are here, project development stage. It's went until February 28. Yeah, and final round it will be at April. We could be present yourself, present your project, and we will see how your progress. And now it's time for your question.
Hello, this is the Spectre team. We want to say something, but in Russian chat. Russia conversation.
You can write it, I think.
Yes, you can write it in our group.
All right, I would like to thank every team that have prepared a presentation or some visual for us to see, and I will encourage every team. Lena, are we going to have this webinars in the future? This type of webinars, where we come all together and talk about projects, or we are not going to? Len.
We will. I think it's possible. We discuss.
Okay. Yeah, so it's not clear yet, but I do really appreciate the presentation, and I encourage every team who were just speaking today to actually prepare at least like one slide or any text or video or animation or anything that makes it easier to understand through Zoom, because it's really sometimes it's hard to get the whole picture through just the speech, especially when the connection is breaking and it interrupts. So yeah, and I believe that a presentation increases the team's chance for adequate judgment and equal and adequate judgment.
I think you actually can use the list of projects that I posted in the chat, and there are all the links to articles of each team.
Yeah, that of course. I mean, whatever I just said would help us in the meetings like that. I kind of figured out that we have a list of projects. Actually, that would be nice to add a link to the report, to the current report inside the page with the project description. Yeah, we can think about it.
The project description article is the same as the report, the current report.
Okay, I'll see.
So the article,
right, yeah.
the article project page changes over time, and always it's the last version.
Okay, cool. Another suggestion, that would be cool for participants to add their team name to the Zoom name, like for the next meeting. Maybe we should advise participants to add their team name to their actual person's name in Zoom. Agree? All right, thank you.
Let's go to idea.
Yeah, I've had a good time.
Thank you.
Yeah, thank you also to everyone, and I very appreciate all your speeches here today, and it's very important because but as better we understood your projects, we can get more valuable feedback for you, and it's of course it's your projects are not ready yet, and but the current stages of your projects and what you're thinking about it now and what you're going to do next is very important. Please share with us, and thank you for sharing it today. And we're here for helping you to make a great projects first of all, and we're happy if you will done a great thing. And we will do our best for help you. And also, I was happy to see some teams from previous CopterHack from 2029. Yeah, very nice to see you guys here on this competition as well. And looking forward for your updates and seeing you next time. Maybe we will organize next webinar, maybe December or January. What do you think then?
Okay, thank you, Oleg. Any feedback? Okay, thank you guys. It was interesting. Good luck and see you later. Bye-bye.
Yeah, I have a question actually. Is it possible to ask? Is not yet.
Yeah, sure. Please ask.
I'm following the plan. So the final presentation should be done in April, right? And will it be fully online, or do you plan something offline like you did last year?
Yeah, it will be pretty same like last year. So the main event will be online, but we will also let you use offline workshop, maybe same in Moscow Institute of Moskovsky Polytech, same workshop, and if it's possible for you, you can go there and participate offline.
Thank you. And as a
so it will be a hybrid format, both online and offline.
Yeah, I guess for us it will be more convenient to participate online.
Online, yeah, no problem. Yeah, you definitely can.
Yeah, and as far as remember, last year you gave, about judging criteria. I remember that there was pretty much points for a speech on the presentation. Is it same this year? I can't see. It's like 3 points maximum.
The judgment criteria is pretty much the same as last year, but for speech, for your presentation, it's not much mark. It's just little points. It's the fewest points in all criteria. In last year was the same. You can check the marking scheme in a page of CopterHack. We published it.
Also, I would like to ask, so do you judge on only final result, or you also take into account the monthly updates we do?
We will judge only final result, only your final presentation and your final video demonstration and your final article. But you have to publish monthly updates for continued participate in CopterHack, because if you don't, you will going out.
Okay, last question. Okay, is it okay to ask? So last year I mentioned that sometimes some teams like did their monthly updates not on time. Is it okay to sometimes violate the deadlines? I mean, so you have to do it in November, but actually I will post it on the 1st or 2nd of December. I guess, is it okay? Or so the question is,
it's a tricky question, because normally it's not okay, but actually we try to judge the whole your project and your team. And if you have a great project and you have every previous update you was made in time, and only last one, only one you made you have made with a little late, probably you will continue. Yeah, but if every update you make late and or you miss some update, I think I think you will stop to participate. But normally it's not okay. So just made updates in time, and will not face any problems.
Okay, thank you very much. Thank you for
Avoid walking on a thin ice. Don't walk on a thin ice.
Okay.